हेलो हेलो। ओके ओके, थैंक्स, मैं देख लूँगा। ठीक है। প্রবীর, একটা ইউটিউব লিংক পাঠাচ্ছি, দেখ তো। হুম, ঠিক আছে। দুবে স্যার,
Yeah. Yes, audible. Yeah.
Yeah, yeah. Am I audible? YouTube Live. Can you send me the link? Send it on WhatsApp, sir. So whether should we stay here or we should join on YouTube Live? We should join.
Okay.
Hmm.
嗯。
Okay.
嗯。
Hmm.
嗯。
Hmm.
嗯。
Hmm.
Okay, good morning. Am I audible? Anyone,
Yeah.
please?
Yes, sir. You are audible.
So, theory and decision making webinar. So, apart from this, we have a problem on different platform. One is Zoom, another is Google Meet. So already we have completed 2 lectures at Zoom platform. So due to everything, after this lecture, all videos I will send to all participants. So don't worry. Hope our speaker, Professor Polas Dotto, will join shortly.
Yeah, I have already joined, sir.
Okay, very nice. So I request Professor Som, this session is yours.
Okay, Professor Jana, thank you very much for inviting the next speaker, Dr. Palas Datta of the country. His research areas are fuzzy set theory, evidence theory, uncertainty modeling, etc. Project of BARC Mumbai on radiological risk assessment during 2009 to 12. Datta is be given the opportunity to start. Okay, so now
Organizing committee, especially Professor Jana, for giving me the opportunity to share my ideas here. So, and also I share my screen. So the topic of my presentation is human health risk assessment and structural failure assessment using credibility theory. See, from the very beginning of existence, human being are always exposed to radiation via natural sources or artificial sources. Basically, artificial sources you can consider industries, nuclear power plant. It may be our water system, such in the release of such system, our water system, our air system. So consequently, what will happen? We will be affected directly or indirectly. Therefore, when release of material, when this product released to the environment, it is necessary to assess health risks. In a similar way, what is structural failure? Structural failure is also we need the assessment. How much? What is the possibility of failure? Right. So come to the main topic. So when we will talk about credibility theory, we have to talk uncertainty. See, what is uncertainty? Uncertainty is nothing. It is if we have a lot of objects, a set of objects, and we have to choose the base object from that set, then the situation is an uncertain situation. Our height of a population varies person to person, so it's called variability, imprecision, vagueness. Characterize uncertainty into 2 ways. That is, one is aleatory uncertainty, another one is epistemic uncertainty, right? Aleatory uncertainty generally arises due to randomness, due to variability, due to stochasticity or behavior of a physical system. Once aleatory uncertainty occur, okay, fine. Now come to epistemic uncertainty. Epistemic uncertainty arises due to imprecision. Okay, then aleatory uncertainty can be handled by the well-established probability theory, the tool. Then here we will basically talk about use credibility theory as a part of this uncertainty theory. What is credibility theory? Suppose then POS is a possibility measure, then this theta, then P and POS possibility measure is called a possibility space, and fuzzy variable is a function. Remember, then fuzzy we have this possibility measure. Possibility measure is also a function from and this power set to set of real numbers such that possibility of the whole set is 1, possibility of empty set is 0, and possibility of union of all events equal to supremum of the possibility of events, right? In this way, we can say about if theta be the non-void set of real numbers, and a fuzzy variable is defined as this way. It is already defined by Jade in 1965, where this is the membership function. Similar, this is a kappa cut or alpha cut, you can say. This is very familiar. So finally, if this is the by this expression, right? This is minimum of twice. I'm coming credibility of this mass equal to n1, minimum of this credibility of this mass n1. I'm coming to credibility measure. Starting a credibility measure is a non-negative set function satisfies the following conditions. Credibility of this one, this is monotonicity, and this is their credibility of the set plus credibility of its complement is 1 for any set, and this is credibility of union of this mass equal to supremum of credibility of this mass is strictly less than 0.5. These are already defined by Bowden-Liu. And a fuzzy variable is given suppose, and its membership function is mu, then credibility of this mass is half of supremum of this membership function plus 1 minus supremum of this mass for a condition. Then this is credibility distribution is nothing. It is a function again from set of real number to close 0, 1 close interval. Credibility of theta such that this is less than equal to this mass. Sorry, this will be clear from this particular examples. Suppose this is a fuzzy variable. This is triangular type fuzzy variable, right? And this is the membership function of the fuzzy variable. Then its corresponding credibility distribution will be this mass, right? And its graphical representation is this is a triangular fuzzy number, and its corresponding credibility distribution is this is. Similarly, suppose this is a Gaussian fuzzy number, fuzzy variable, then this is a general Gaussian fuzzy variable, and its corresponding credibility distribution is this one. Similarly, suppose this is a Cauchy fuzzy variable or fuzzy number, you can say, and its corresponding credibility distribution is this much. Credibility distribution. Now come to the probability distribution. We all know that what is probability distribution is to X is a continuous random variable, and a probability density function must be then for if X lies between minus infinity to plus infinity, this is R. So come to normal probability distribution. The normal probability distribution is defined as this way, and its corresponding cumulative distribution function is this one, right? So this is these are corresponding CDF. For this PDF, its corresponding CDF is this one, and similarly for the others, their corresponding CDFs are these. Now come one of the important technique, that is sampling technique for credibility distribution. Like probability distribution, we can perform sampling distribution for credibility, right? For this purpose, we have one close interval. Then using the that generated random number, say it is 0.9, then using the inverse part of the function, we can use only generated number is 0.9, its corresponding value is this one, say. This technique is called sampling technique. An arbitrary model, say this is f of from all the fuzzy variables into credibility distributed random numbers from variables. That's why we have to generate n numbers of uniformly distributed random number from 0, 1. Then we will use this sampling technique for the credibility distribution. then we'll plot CDF of the and output model values. And suppose this is a function a into b, first convert them into then suppose define factorial. It may be factorial means corresponding Rix value, the model value will be this much 0.85 fractal, say it will be other value. In this way we can evaluate the model value at that for under fuzzy environment. And this is for suppose a hybrid environment. Hybrid environment means if some variables parameter of the model are, say, so here see this is the model, the first component say fuzzy variable represented by fuzzy variable. Here what we will do, we will tend in the second step we will do consider all credibility distribution and cumulative distribution of the fuzzy of the uniformly distributed random numbers from 0 1, because why it is m plus n, because you can see there are to use sampling technique for the credibility distribution and cumulative distributions to generate m plus n number of random numbers. We will input all this m plus n the number of it will give n plus n number of random numbers of values in the model. We will input in the model and then we will plot the m plus n output values, and similarly we will evaluate model values at different fractals, right? For example, variables representations are fuzzy variable, while representation of B is probability distribution. Say this is fuzzy probability distribution, so we have considered its corresponding what CDF plus say this is another fuzzy variable whose corresponding credibility distribution is the figure this much. So say the out consider what we will evaluate Rix value or model value at defined fractals. It is at 0.9, it is say Rix value, and we can evaluate it at 0.8 or 80%. At 0.8 it will be another value. In this way we can evaluate the model value at different fractals. So come to the our problems. As we have already said, I have already said that we are exposing radiation from natural sources and artificial sources as well. Artificial sources are industries, say this is the one industry, say, which produces what smoke and release to the environment. Similarly, another say industries, and what they are doing, they are throwing or releasing their waste material to the soil or water system, you can say. Similarly, other industries throwing their waste product to our soil. So consequently what will happen, we can say the first is a pathway, we can say it is called inhalation pathway. By as the smoke goes to the air, so air will be polluted, and so breathing of such air we will be affected, right? So similarly, another takeaway, intake of water. If the materials or waste product goes to go to the water, and taking or intake of such water will be harmful, will be at risk. Similarly, so it can be say as a intake of water is a pathway, right? Another pathway is ingestion of food. Suppose due to release of this waste material into the environment or basically in soil, then production of any vegetable, say, and consuming of such vegetable may affect us. So this is another pathway called, we can say, ingestion of food, right? Now come to the health, different various type of health effect. First one, we can say acute radiation sickness. These are the some pictures of acute radiation sickness. Cancer damage or hereditary property changes, you can say. This is fatal damage, maybe bone you can see the characteristics of parents may be different in their child, right? So hereditary changes may occur. Now come to the model and then the problem. We have taken this model from EPA 2014. EPA means Environmental Protection Agency USA. They have defined this model. This is chronicle daily intake CDI, and CF is nothing. It is the chemical concentration of fish tissue into FIR. FIR means fish ingestion rate. FR means fraction of fish from contaminated sources. Then EF means exposure duration, ED means exposure frequency, ED means exposure duration. Then similarly, this CF means conversion factor, it is defined by EPA. Then body weight and average time. So ECF means predicted environmental concentration and chemical bioaccumulation factor. It will give by this expression. And finally, RIX will be CDI upon RFD. RFD means reference dose. All are defined by EPA, right? So finally, we will have the RIX model. This is the RIX model. So now consider a case study for the model. Suppose average time is 25,550 and body weight is a fuzzy variable, say. ED also fuzzy variable here. Similarly, EF is a fuzzy variable here and FR is fixed 0.5. FR is a Gaussian fuzzy number and PC is fuzzy number here, Cauchy, and BCF is also say Gaussian fuzzy number, right? These are the value of the parameters. The representation, most of the parameters representation are fuzzy number, fuzzy variable, and some are constant. So after performing the model, we will have this sort of credibility distribution, right? What it will give actually. Now we can evaluate its RIX value at different what it is called that different fractals, right? So now come to the result. If we consider fuzzy environment completely and we evaluate the RIX model within the fuzzy directly using the fuzzy concept, then the value will be around 3.7, means it's again a fuzzy number around 3.743 into 10 to the power 9, and initial value is this much and end value is this much. Now using this credibility measure, we have that at 95th fractile its corresponding value is 5.485 into 10 to the power 9, means this is the RIX value at the level that is confidence level 95th, that is we can say 0.95. Similarly for 80% or 0.85, its corresponding 0.85, its corresponding RIX value is 4.926. Any question? Okay, this much. Similarly at 65th fractile the value is this much, right? In this way for the various fractals we have evaluated its values, that is that will be RIX value at we can say occurrence of RIX value at various fractals or confidence level. In a similar way, we can consider a hybrid situation. Say here we can see this ED and EF, their representation are probability, and say their these are probability distribution, normal probability distribution and Cauchy probability distribution, right? And here you can see body weight is again a fuzzy number, and here BCF is also a Gaussian fuzzy number. Now if we evaluate, then using the algorithm, second algorithm, this will be the corresponding, the resultant credibility distribution, right? Or you can say cumulative, because finally we draw the cumulative distribution. Basically it will be better if we say cumulative density CDF. Okay, fine. So again at defined fractals, at 95th fractal for this environment, the value is this mass. This is the occurrence of Higgs value at the confidence 95th. Similarly, the Higgs value is 6.854 into 10 to the power 9 for 85th fractal, right? And similarly, these are other Higgs value for other corresponding fractals. Okay, now come to
Hello, Palash sir, is there any problem? Hello? Hello?
Probably net connectivity is not there.
Oh, sorry.
Maybe. These are the difficulties generally we face
Yes, Professor.
in online programs. Probably he's joining again. Please make a call to him whether he is able to connect or not.
Yes, sir, we are trying.
I think I was disconnected.
Yeah.
Okay.
Okay, now you should start again. No problem.
Yeah. Okay. Thank you. Just a second. We have come across all these things, I think. These are the health effects I have already told. Okay, and this is the Higgs model.
It is okay.
It is okay. Okay. This was case 1. Case 2, here we have considered hybrid situation, right? This is the output, that is the graphical representation of the CDF, and this is the results of the at different fractals, the risk value is this much, right? Okay, now come to the structural failure.
ওই রাস্তায়
Hello?
ছিল মাঝখানে একটু খোলা আছে একটু খোলা আছে
Okay. So structure, these are some photos of structural failures. As I have already mentioned, that structural failure refers to the loss of load carrying capacity in either a structural component or structure itself. So structural failure is initiated when a material is stressed beyond its strength limit, causing fracture or excessive deformation, right? Basically, reason of structural failures are, we can say, defective design. It may be inferior construction material, or it may be employment of unskilled laborers. So, and one thing we always remember, the design of structure should satisfy three fundamental things. That is, one, stability. That is, we can say it should be stable under the action of load. Strength, another one, that is it should resist safely stress, right? Then serviceability. Serviceability means it should perform satisfactorily under service load. So it is always required to assess the failure, right? Now come to the methodology. Suppose this is a reference function, as is a model of fuzzy variables, right? The components of the structural failure model or reference function is fuzzy variables. And so in the first step, we will convert all the fuzzy variables into CD means variability distributions. Then we will generate WI, means how much amount number of variability distributions are there. So WI, number of uniformly distributed random numbers, as earlier in the RIX model we have done. Then in the next step 3, we will generate random numbers Ri by transforming Wi using the inverse transform method, or we can use sampling technique for variability distribution. We can use in step 3. Then we will calculate the model for these values. Then see, this is the important step. Failure take place if the value is less than equal to 0. Say that is, failure domain will be minus infinity to 0. Then the failure of the structure can be evaluated how? In case 1, for m belongs to m star, if the value belongs to this interval, then correct value means this failure value is 1. And if it does not belongs to this interval minus infinity to n 0, then the failure value is 0. And finally, we will repeat the process for, in this way we will have one value, repeat process for n times. It may be 1000 times, 100 times, 2000, 3000, right? And finally, what we will do, we will evaluate the structural failure using sum of the earlier grade values by number of the simulations, right? Now consider a very simple example. Suppose a bar R, capacity R and load S, say, and the limit function or reference function is this much, R minus S, is capacity minus S. This is a very simple model. And say representations are here fuzzy variables, and first we will convert them into variability distribution, and we will follow the algorithm. Then we will have this sort of failure value. For 100,000 simulation, we will have the value is 0.2520. It will be 0.2512 for 5,000. For 10,000, it is 0.25. For 1 lakh, 1 lakh, it is 0.2499, and for 10 lakh, I think it is 0.24, which is very similar to this much. So, and this is the graphical representation. See, this portion lies between 0 to minus infinity, means for this portion the structure is failed, say. So the portion is very smaller, and The non-failure portion is bigger, so it is definitely the possibility is smaller, right? 0.25, or it is 0.25, around 0.25, right? For various simulation, the value is very similar, right? In another example we can consider here is a model, right? This is the reference function, and for its beam of length, this mass, and height 8 mm, force density this one, and load W is this is a Cauchy fuzzy number, right? A normal probability distribution W. This W is normal probability distribution, say, and M naught is normal. What this is fuzzy number. Normal means this is probability distribution, and B is Gaussian fuzzy number, fuzzy variable. And using the above algorithm, we'll what have at this sort of failure value. This is 0.25 T0 4000 and 0.2442 for 5000 simulation. For 10,000 it is 0.45. It is 0.24 something. It is very around, right? 0.2411, and its corresponding graphical representation is this mass, right? And this is for 10 lakh simulations. So what we have discussed in our lecture, risk assessment. Why we need a risk assessment? Because due to release of waste product to the environment by various industries or man-made, it is generally man-made industries, that our system, our environment will be contaminated in 3 different ways. One we have discussed is inhalation, another one is intake of food, then another one inhalation. There are 3 pathways. Another one pathway is there, that is called dermal contact. If we use such contaminated water for, say, taking bath, then our skin will be harmed, right? So this is called dermal contact. So, and accordingly we need, when this sort of waste product released to the environment, we need risk assessment, right? And in the same way, for structural failure also we need the assessment how much it is failed, right? And for this we use the algorithm. And I think with this I thank you for your kind attention. Thank you.
So, Professor Som, please unmute yourself.
Any question from audience? Hello, any question? Anyway, let me ask one question since there is no other question.
Okay, sir.
Can you just give a relationship between credibility and uncertainty? Is there any relationship?
What uncertainty? Yeah, credibility means, you see, when you have uncertainty means if uncertainty arises due to imprecision, due to vagueness, right? Then then you can represent this uncertainty by fuzzy variable, right?
Okay.
Okay, then from this fuzzy variable you can construct your credibility distribution directly.
Okay.
Right?
So ultimately they are related.
Yeah, they are interrelated.
Is there any mathematical form?
Yeah, I have already
Okay, you given that one. Yes.
Yeah. Let me see you again. Yeah. For this is a triangular fuzzy variable. Say its corresponding credibility distribution is this much.
Okay.
Right, sir?
Okay. How these two are derived from the 1 to 2?
1 to 2, it is already defined, sir, by Baudin-Leo.
Okay.
This is the definition. Right.
Okay. It was a very good talk by Dr. Palas Datta. So let us give a thanks or applause from our.
Thank you. Thank you.
So let me thank Dr. Jana. I think I have to hand over the mic to Jana.
So
Dr.
thank
Jana.
you, Professor Som. So our next lecture will be start at 2 p.m. So all participants, I request please join in the next meeting at 2 p.m. So thank you for joining. So I declare this session is end here. Thank you very much.
Okay.
Thank you.
Fine.